Let's go slowly code 1671. Minimal number of removals to make an array, mountain array. And so it gives us an integer array and define an array as mountain array if the array length is greater or equal to 3. And there exists some index that index I. And those kind of index I smaller than index on the left, it will strictly increasing, and on the right, it will be in strict decreasing. So giving a nums array, return the minimal number of elements to remove to make a nums a mountain array. So for the first question, we'll say if the index I is at 1, right? And then on the left, it is strictly increasing, and on the right, it is strictly decreasing. So we don't need to remove anything. And example 2, we can remove at the index 0, 1, and 3, 4, 5, and index 5 to make the array as 1, 5, 6, and then this one, right? 0, 1, 2, 3, 4, 5, and to have 1, 5, 6, 3, 1. And we'll say it is the mountain is at index 6, right? So we can just need to remove 3 elements. So how can we do this question? We know there is something called longest increasing subsequences, right? So, but that for that question, longest increasing subsequences is that if we can simplify this question to say how many elements we can remove to make these nums as strictly increasing sub array, right? So we can use the longest increasing subsequences, and the total numbers minus longest increasing, right? But this one is not only longest increasing, but also there is another part that is we need also longest decreasing, right? The reason is that we are not only calculate the LIS for the whole array, but for every index, we want to select the longest increasing subarray, right? For example, at index I, then if for example at index 5, right? If we have 3 strictly increasing, then that means we just need to remove 3 elements to make this part strictly increasing, right? And so that means for every index we should have a record to store what is the longest increasing number, right? So we can pre-process to get an array about the longest increasing arrays subsequences numbers here, right? For every index. And on the other side, we need another array, which is the longest decreasing subset array, right? Just for every index I, we want to see this decreasing is from I to I minus 1, right? So we want to see what's the maximum number which is just strictly decreasing, right? So that we can iterate for this kind of array, right? For this kind of array, iterate every I trying to see what is the longest increasing on the left, what's the longest decreasing on the right, right? So we know the longest increasing on the left plus longest decreasing on the right will be our longest mountain, right? So the final result will be n minus this result, right? So we pre-process an array called the longest called LRS1, right? Which is longest increasing on the left, and LRS1 that is longest decrease on the right, right? Or we can call longest decrease LRS and LDS two arrays, and then for every index, we just iterate from index. Actually, we just say from index 1 to n minus 2, right? Because it um, need at least two elements, right? On LRS and LDS, right? And trying to iterate what's the maximum value for this. If we get a maximum value for this, my final result will be n minus this one will be the minimal to removal. Okay, so let's begin to write code for this. So we're going to have int a equals nums dot length. What we want is we need to have LRS array, right? You can call the LRS nums. And we need an LDS, right? For get LDS nums. So what we do is that we just we need to have max mountain, right? Initialize 0. So what we do is that for int I equals to 0, or I equals to 1, right? 0 to this doesn't matter. And I plus this doesn't affect too much from 0 or from 2 plus. So what we have is the things that we need to say if LSI is greater than 1, right? And LGSI is greater than 1, right? Otherwise, you say that there must have because for this question, strictly increasing or strict decreasing is not considered mountain, right? You say that there exist some smaller and some should have some kind of a change point, right? So then we'll have max equals to max dot max max and LSI plus LDSI minus 1, right? Because this one is easy because it shared one common element at the index I, right? So it should minus 1. In the end, what we need is return n minus max. Here we write a help function private called int get LDS, right? Actually, for this one, we don't want to write multiple code. We just need to, for example, we already have get LRS. Then we just need to reverse, right? So what we need is that first we can reverse these nums. Reverse equals int string range from 0 to um, int a equals nums dot length range 0 to n, and then we are going to do a map I goes to nums I minus 1 minus r and to our so we are going to have int reverse list, right? Reverse ls equals get lis reverse one. And in the end, what we need is return. For this one, we also need to reverse, right? So that will be int string range from 0 to n. Also map my goes to RLS n minus 7 minus 1, right? To array. So this is so we just need to write a get ls function, right, for array. So what we need is that private int get ls nums. So what we do is the ls, there are two ways. One is use to for loop to do the dynamic programming, right? Another is like a binary search way, right? So we have, if we use a binary search way, the time complexity will be better. So that means that it will be, we'll set initial index as -1 and have n equals nums dot length. So we need this kind of result equals new int and we need an array to because we don't want to change the original nums array. So to store those kind of elements, right? So we can do also have an int. Therefore, int I equals 0, I smaller than n, I plus plus 1. What we do is that int num equals nums I. And we are looking for, in this kind of array, right? We are going to put this kind of the things that we put for binary search way is that if there is a number, if the array is empty, we put that in this kind of array. If not empty, we binary search in this kind of array, right, from 0 to index to find the first number greater or equal to this num and replace with this one, right? And the result will be this kind of index +1 means it's a size, right? So what we do is that we are going to have int SID equals binary search. We are going to rewrite this binary search, this array, and from 0 to index. And we are looking for this num as target. So if SID equals -1 means we didn't find element greater. Let's write this binary search. Binary search. That is int array, int index, int target. So what this do is search in array the first greater first index greater equal to target. Right? So if not found or array is empty, you will return if not found or array or index is -1, right? So return -1. So if si equals -1 means we need to move our index, right? And add this one to this none. Else, we just set this array, the SID, right? The final one was none. So our result I will be always index +1, means how many numbers can be the longest increasing, right? In the end, just return the result. For the binary search, we say if this index equals to -1, right? We should return -1. And we have start equals to 0 and equals to index from search from 0 to index. And while we start +1 smaller than n, we're going to have intermediate equals start plus and start divided by 2. So if array middle is equal to, right? Equal to means because we are going to find the first greater equal to, so that means we should still search to the left part. So if it's equal to or it's greater, it's also need to find the left part, right? That is the end equals mid. That means if this is smaller than target, right, then we'll have start equals mid, and else we'll have end equals mid. So we'll say if array start is greater equal than target, return start. We also need to check end if it is equal to target, right? Then return end. We should both check start end because it's possible start end. Yeah, now that is greater equal to target. If now that greater equal than target, what we do is return -1. So this will be the code. It will be, you see, we are composed the LRS. This is a in log n time complexity and then O n space complexity. And for this kind of iteration, right? That this is O n. So it is n log n time complexity and n space complexity. Python code will be very similar. Let's write the Python code as well. So we're going to have n equals the length no, and LIS equals get LIS, and LDS equals get LDS. Right. So the things that therefore get LDS nums, right? It's nums. So the things that we have reverse equals nums, just reverse this, right? And reverse ls equals get ls reverse and return ls this one, right? This is get lds. And for the main function is that we need a max length equals 0 for I in range from 1 to n minus 1. If LSI is greater than 1 and LDSI is greater than 1, right? Then max length equals max length and LSI plus LDSI minus 1. And in the end, return n minus max length. So we also need to define the get ls nums. And what we do is that we can have this verb is also right. So what we need is we'll have array equals this one multiplied by n, and the result we should also have this one multiplied by n, right? And we have index equals minus 1 for I in range n. We're going to have num equals nums r. And we're going to have S index equals binary search array index num, right? Of course, we need to write a binary search. So if S index equals minus 1, we're going to have index plus equal to 1, and then array index equals none. Else, what we do is that the index minus 1 means the original it is that this array is empty, or we didn't find in array an index that which is greater or equal to none, right? So that we append a new one. Then we're going to have array SID equals none. And we're going to have result I equals index plus 1. And then just return result. So we also need a binary search def. Let's search, for example, search an array, search an index, and search an target. So what we need is if this index equals minus 1, because this array is empty, just return minus 1. We didn't find any. Then start and equals 0 and index. After a while, start plus 1 smaller than end. We'll have mid equals start plus end divided by 2, right? So if array need, if this one is smaller than target, right? Then that means we need to search on its right. So we are going to have start equals need, right? And if this one equals target, we still need to search to its left. So that, and also if it's greater than target, we will still also need to search on its left. So that we can write else and equals need. And after this while loop, we check both start and end, right? If array start is greater equal to need target, return start. If array end is greater equal to target, return end. But it's possible that both start and end does not satisfy the condition, right? It's -1. But this binary search is search the first in array, the first index greater equal to target, right? So if array empty, right? Empty, that is the index equals -1, or didn't find an element greater equal to target, return -1, right? So this will be the code.